Hello friends, today I will explain that the calorimeter practical in physical chemistry or thermochemistry. The aim of the practical determination of enthalpy of neutralization of hydrochloric acid with sodium hydroxide to the calorimetrically. The experiment having theory of the heat of neutralization. The heat of neutralization may be defined as the amount of heat evolved when 1 gram equivalent of acid completely neutralized with 1 gram equivalent of the base or vice versa in dilute solution according to the Arrhenius strong acid and base completely ionized in aqueous solution. Hence the neutralization of a strong acid, that is the HCl, and strong base may be defined as, that is the NaOH, may be defined as HCl plus NaOH to give the reaction in H plus Cl minus plus Na plus OH minus to give Na plus Cl minus and H2O, that is the 57.3 kilojoules. Apparatus for this experiment: thermos flask with tight fitted cork, 250 ml beaker, 100 measuring flask, 1/10 degree thermometer. Chemicals of this experiment is 0.2 molar HCl and 0.2 normal NaOH distilled water. Procedure of this experiment: to determine water equivalence of calorimeter. Clean the calorimeter, take 100 ml of water in it and note its temperature. Second is in a separate beaker, take 100 ml of water and heat into the 15 to 20 degrees Celsius higher than the room temperature. Add hot water quickly to the cold water in the calorimeter. Replace the stopper and stirrer with the stirrer and note the temperature of the mixture. Next, to determine the heat of neutralization of HCl with NaOH, that is the fourth point, take 100 ml of 0.2 molar HCl in a clean calorimeter and note its temperature, and take 100 ml 0.2 molar NaOH and take the temperature must be equal to that of the HCl. Otherwise, wait for some time till both the solution attain same temperature. 6 point is for 100 ml of 0.2 molar NaOH solution quickly into the HCl solution in the calorimeter, taking care to avoid splashing, and stir well and note the highest temperature attained, that is the observation. For the water equivalent of calorimeter, volume of cold water is 100 ml, temperature of cold water is the T0 degree Celsius, that is the cold water's temperature. Next, volume of the hot water, that is the 100 ml, the temperature of the hot water, that is the T1 degree Celsius, temperature of the mixture, that is the T2 degree Celsius. Density of the water is the 1 gram per ml. Next, for the heat of neutralization of HCl with NaOH, volume of the 0.2 molar HCl taken is equal to 100 ml, volume of 0.2 molar NaOH taken in 100 ml. Initial temperature of HCl and NaOH is the T3 degree Celsius and final temperature after neutralization T4 degree Celsius. Calculations: to calculate the water equivalent, next rinse the temperature of cold water, that is the T2 minus T1 degree Celsius. Fall in temperature of hot water is the T1 minus T2 degree Celsius. Let W is the water equivalent of calorimeter and its content. According to the principle of calorimetry, heat lost by hot water is equal to heat gained by the calorimeter and cold water. W is equal to 1000 T1 minus T2 into bracket T2 minus T0 minus 100 gram To calculate the enthalpy of neutralization, initial temperature of HCl and NaOH before mixing, final temperature after mixing T4 degrees Celsius, range in temperature T4 minus T3 degrees Celsius, total volume of mixture in the calorimeter is a 200 ml, heat of neutralization of 1000 ml of 1 molar HCl, in a given formula 200 plus W T4 minus T3 star 4.184 upon 0.2 star of the 100 kilojoule is equal to Q kJ. Enthalpy of neutralization of HCl with NaOH is equal to Q kJ per mole. The result of this practical, the heat of neutralization of HCl and NaOH is equal to in kilojoule. The actual value is minus 57.3 kilojoule and percentage error. This is the practical for the thermochemistry in a calorimeter. Result and precaution of this practical, the use of the very accurate 1/10 degree thermometer. The bulb of the thermometer should not touch the bottom of the calorimeter. The solution should be thoroughly stirred while noting the temperature. And fourth one point of the precaution, the solution should not splash out when poured from beaker into the flask. Thank you for and watching the video.